Aspetta un attimo, allora che devo sistemare una cosa. Non volevo mostrare. Prova. Ciao. Okay. Okay, no, I think we can get started. Usually in this position, I get okay, welcome everyone. Make for tonight. I know that it's not the ideal time of the year for going to meetups, but I'm glad for whoever managed to join. A very short introduction, like 2 minutes, an institutional introduction on Alkemy, the place where we are having this moment. Alkemy is a consulting company, even if I shouldn't say that, because we are actually a company that help other companies evolving in the post-digital scenario, but it's too long as a definition. And it's a company with over 1,000 professional people working in Italy and also in other countries, namely Serbia, Mexico, I don't remember, a few other countries. The mission statement of our company is that we design business solution through data, technology, and creativity. And despite being an important statement, I believe it's not far from the truth. Meaning that we really help companies as much as we can in evolving in their business journey, and we really leverage, especially in this point, data, and I represent the data pillar, being part of the data analytics competence center, but I'll tell you a little bit more on that in a second. We of course rely on the technology and the techniques that are needed to use data, but creativity is really probably distinctive part of this company. Maybe you feel it also from this space, maybe not so much, but if you visited the rest of the office, you would notice that we have, in fact, an entire agency of content creators for, and also an entire agency of designers. our story started a little bit than 10 years ago with a small amount of people, and today we are in more than 1,000. Noticeable to be noticed that we incorporated design of Italia for the people into design is really an institution, and also other acquisitions. Uh, our main competencies are these ones. Data analytics are the people like me that are involved in data science projects, but we also go into marketing and digital marketing, brand and product experience, and this is also product design and service design and every kind of design, technology and consulting. So we also provide some strategic consulting service, uh, the Alchemy way, I would say. We are in different cities in the world. Spain actually is the biggest country after Italy, so I forgot Madrid. And finally, okay, we have many clients. We have values, okay, and maybe well, data analytics, we measure and response. I just wanted to share this number, meaning it's really a big bunch of data analysts and data scientists. It's not a usual fact to find in a company of this size so many people involved in data. It's more than the 10%, which is interesting to notice. Uh, Finally, I'm part of a subset of the data and analytics competence center that is called Deep Learning and Big Data Department, which has even a fancier statement, mission statement, AI and ML solutions for real-world problems from R&D to deployment. What does it mean? That we are trying to push what Alchemy knows and can do on data science through three areas: R&D, which is researching on the latest developments in deep learning and machine learning; infrastructure, that is researching and applying stuff from data architectures and the data engineering field; and finally, education. We do a lot of courses for other companies and also for our colleagues. Now, so this is the place where you are now, and especially deep learning and big data. Around 1 year ago, managed to get in touch with the BRIO project, and I'll let Greta introduce it. That is a university project. So we signed an official partnership between Alchemy and BRIO. And it was an amazing experience of this year. And tonight we will tell you what we managed to do and what we want to do next. So, Greta, I'll let you go on with this.
Thanks.
And you have also the.
Nice.
But it's a little bit blurred.
Of course it works.
Okay.
Thanks. All right. Well, first of all, thanks for having us here and for letting us present this work, which is joint with Alchemy, as Davide was saying. So the tool we will present today is actually a bias detector tool, but we'll get to that in a second. So my name is Greta, and I'm from the University of Milano, and we've been working on this stuff for some time, so we're going to show you what we did up to this point. Okay, so what's gonna? I know. Okay, so I'm sorry for those behind them. Yeah, sorry. Okay, so today we're gonna. I'm gonna start by telling you what is the problem that we're trying to address and what our algorithm does, and then Davide is gonna give you a live tutorial of the tool, and he's gonna answer all of your questions. So it's gonna be very easy for me. Okay, so Davide mentioned BRIO, which is the university project that we are in, And that's kind of an acronym for the three words: bias, risk, and opacity. So these are the things that we're trying to look for in AI and hopefully do something about it. So the project, with the part of the project, of the BRIO project that we're trying to do with Alkemy is actually produce some open source software that you can already find in our Git repository. And the part that I'll be telling you about today is actually only the part on bias, because that's what was the title, and but we're working on more stuff. Okay, so the first question we should ask ourselves is, what does it mean for an AI to be biased? And the first question would be, why do we care? Well, there's many instances where AI is already used in real life problems. So for example, what you see here is a model trying to predict recidivism for crimes, right? And you'll see that, well, you can actually see that, but the algorithm acts quite unexpectedly, or perhaps not unexpectedly, regarding people of color. So a person of color that has less offenses than a white person gets actually rated as high risk. So of course, if you take this approach, this is actually a tool that was really used in the United States up to a few years ago. Of course, we know what taking that to the far end gets. But for less dramatic reasons, also our job applications are scanned by AI, as you may know. And so, for example, companies, I don't know about Alkemy actually, but I don't want to ask. Your values. Companies are using algorithms to scan our job applications, so we should be concerned about that. Okay, before we move on, I want to introduce two technical definitions, kind of two things that we might want to ask of our algorithm. So the first thing is called demographic parity, and it means that the result does not depend on a given feature. So, for example, we might want our crime predicting algorithm to not focus on race. Yeah, and the second is equal opportunity. So the result does not differ between equal individuals with respect to a given feature. And this means, for example, that if we have a job application scanning algorithm, then two equally qualified people should not be distinguished based on their gender, for example. And so why do we think that algorithms are biased? Well, there's many reasons for that, as you may guess. So first of all, the data is often biased. So for example, you've seen that the number of computer software engineers were mostly men and white. So the data is already biased. Neural networks do what neural networks do, but it means we don't have much control on what they do, like in detail. So that may be a cause of bias. And maybe there's many more reasons that I don't know that you can tell me about. But the fact is that the algorithms are biased. So it means that we can do either one of the two things. And the first thing we can do is train algorithms so that they are not biased. Of course, this is very difficult to do, but the point is that the specifications that we give actually guide the algorithm, and there are all the laws that the algorithm can know. So we can train unbiased algorithm, or if we already have algorithms, we might want to check if they are biased or not. And so this is the thing that we'll be talking about today. Yeah? Okay. Maybe I'll stop for questions in a while. I just want to finish the introduction. Yeah? Okay. So to check bias, there is two main perspectives that we can take. The first is we call verification, meaning that an execution must satisfy a normative definition with respect to some property, meaning that we want to compare the system to our model. And the second, which maybe will help into comparing and understanding first, is what we call validity. So it means that my model must correctly model reality as it is intended. So you see that these two are kind of different. But this is the point where the university comes in, because highlighted some words, and maybe if you remember from your school or from university, these are words that are actually quite much used. Logic. So this is why we're here, because maybe logic can help, because the words are the words of logic, so maybe we can apply some of the things we know to this problem. Okay, so I know what you're thinking, probably, like, logic probably isn't a thing that you thought you could apply to this kind of stuff. Maybe you remember this kind of list of symbols from when you studied what the definition of a limit in a high school. So yeah, logic actually is a bit more complicated than what you remember. So I wanted to just show you a page from one of the papers that is cited in the bibliography of this work. So a lot more symbols. And actually, Francesco gave a talk, and he truly put this slide. A simple example, yeah. This is. So it's not what you remember, but that is the starting point for it. Okay, so we want to detect bias, and we start from some theory. So here's a bunch of papers that contain the logic that I was telling you about. And then out of this, we produce a software. So here you see a kind of a upper view, kind of a bird's eye view of the software. So I'm going to explain each point individually. But okay, so we can go from the theory to the software, and we already did that, luckily for you. So there is some customization happening, but I won't tell you about that for the moment. So just before we stop for questions, can we? Is that a problem?
Yeah.
Okay. I want to tell you what this is and what this is not. So as the title said, this is a bias detection tool. So it means it's not a correction tool. So in the different strategies, either to detect or to correct, we chose for the moment to focus on detection. And the point is that a correction tool, if you read something about this, focuses on optimizing some sort of loss function. And the loss functions is defined assuming that a correct label is known. So typically you have an input, you know what the output should be, and you want to figure out how much you can kind of shorten the distance between the two. So this is not what we do. Because our focus is more post-processing, and it focuses on the frequencies. So even if it seems like a losing strategy, the advantages of this is that this is blind to the model. So we don't need to know what your model is, we don't need to know what your model does. We only need to know what your model does, yeah? So it means that if you have, I don't know, proprietary software, secrets and stuff, we don't need to know about all of that. And this is kind of different from feature weighting, and we're gonna focus on that in the second module of the project. Okay, so I guess it's a good point to stop for questions. Does anybody have any? Yes, please.
You say it's blind to the model, but you do assume that it is a binary classification model, right?
Yeah, well, not necessarily binary, but working on a variant that actually does not presume that, but yes.
So it's a classification model, but you don't care whether it's a neural network or
yeah, exactly. We don't need to know anything about the model, we just need, well, maybe it's here. Ah, okay, this, okay. So you just need to the test set and the outputs on the test set. More question? Yeah.
Question, I guess maybe it's not really specific to the software, more of the general topic.
Yeah.
So, why I'm not into this bias, but the idea is that, so let's say you identify a feature as providing bias into the prediction.
Yeah.
And this is unfair. I could say that the famous algorithm was predicting everyone who's black was a criminal.
Yeah.
So it's unfair at the individual level.
Mm-hmm.
But is the bias model at the population level more performant than the unbiased model? Because someone may say, as a customer, or may say, okay, thank you, now it's unbiased, but it's reducing performance.
Yeah. There is a big question. There is some work that correlates the two, like it doesn't necessarily reduce performance to too much, but maybe we can discuss that afterwards because it's actually quite a good point. I mean, if you take this, of course, to the extreme, it means like the most unbiased model would be just flipping a coin, and you don't want that, of course. So this is about just having a way to speak about this so that you can set a boundary, basically. Yeah. So in a sense, there's always gonna be some bias because you choose. Yeah. But the point is that you want to have some standard that is not kind of gone over. But maybe we can discuss that after because that is the question, of course.
I was wondering which are the main kind of biases that the tool can detect, and also which are the skills of the people involved in setting up this sort of tool.
Okay.
Which is the background.
Okay. So to answer your first question, Davide is gonna have a kind of a tutorial, so he's gonna show what happens like hands-on. And then if your question is not answered, then we can talk about it again. And the second is, you mean us? What do we do?
Because it's you and your colleagues that are, setting up the tool.
Yeah.
So what is your background?
So my background is in math. We all do logic. These are philosophy departments, and then there's of course people in alchemy that have values and stuff.
I knew you would. Maybe it's worth saying that the tools don't not require any hardware expertise, right? So the idea is that a potential user will use it, and I suppose when you will see the tool in action, you will sort of recognize it. It's supposed to give information about potential situation of biases without requiring you really to have to understand all the math. Right? So the type of approach is really as user-friendly as possible. I also wanted to say, Naya, with respect to your first question, so the type of bias, so there is currently literature is enormous, right? About whether bias is historical data or whether bias is generated by a selection, right? With respect to the tool though, it doesn't really, we don't really care why the data is biased. We only care to understand whether there is a bias with respect to some feature. So what we want to point out through the use of the tool is whether any specific feature of the model that you are using might produce a difference with respect to individuals or group of individuals, right? So essentially you don't need to know where from, but you need also to know that there is something that is going to make wrong.
Yeah, and on top of that, as Giuseppe said earlier, we're not saying like this algorithm is good or bad, and we don't decide what's good or what's bad. You simply
you flag that
you flag stuff. Yes, precisely. So the other input that you can give is you can select a feature that you want to investigate in a sense. So, for example, in the case of the crime predicting algorithm, you might be interested in race, but for whatever reason, you might be interested in income. So you can flag that and see what happens. So we don't give any judgment of any sort. You can select whatever you like. Got a question? Okay. So I'll just go through the structure of the algorithm very quickly. Okay, so you put your test set and the output of the test set, and then you select what feature you're concerned about or what feature you want to investigate. So, okay, this is an example that we actually, like a real life example that we checked. So you have a database of individuals with their age, their sex, income, education, and such, and an algorithm predicting whether they are likely to get a loan from a bank. Okay, so it's a typical case. For example, you want to check education. So maybe if an educated person is more likely than an uneducated person to get the loan. And then we get to the main part of the algorithm. So what does it actually do? So the first kind of analysis we call FREC versus REF. So you basically have in mind an ideal configuration of how the algorithm should work. So for example, if you have men and women, you want to have 50-50 kind of distribution on how the algorithm works. And the other one is the FREC versus REC. So for example, you consider, you take your feature, education, and you want to see what happens to subsets of that. So for example, an educated person, is it more like, does it change for an educated person the age that the person has or the gender of the person? And so these are the kind of the two main options. Of course, for the first one, you need to have an idea of what your distribution should be. Well, this kind of works with all subsets, so it's kind of always possible. And then the algorithm produces a list of violations, which I'm not going to explain because that's Davide's job. But of course, you see a lot of number and violations and strange things. And how do we get this? So this is the point of customization. So we get back to that. So you need to decide which threshold you don't want to get past. And so these are a few features that you can use. So you can select the distance because, of course, you want to compare how far you are from the optimal situation. You want to have, as I said, a threshold for your tolerance. And you want, well, you don't care about this. So the threshold you can either select manually. So for example, you say, I only happy if they are distant 0.001% for whatever reason you know. Or we have an automatic way of selecting the threshold. And then it depends on a few properties of the algorithm, which I'm not going to focus. I can tell you about this if you're interested. One interesting thing about this is that our algorithm allows you to select whether you want to be more tolerant or less tolerant. So for example, you can select these features such that you'd rather have a false positive than a false negative. A false positive, yes, than a false negative. So for example, when you're predicting, I don't know, if a person has a disease, you'd rather have a healthy person get a positive answer and investigate more than the other way around. Okay? So the question is, okay, we did a lot of things, we use logic, we put numbers in it, does it work? And we actually tested this on the data about the loan that I was telling you about. And we trained 3 models, and we conducted a few experiments on them, and you can read them in our repos. And actually, we found that the algorithm kind of worked quite well, and some things happened. So, for example, the more powerful the model, then the more biased it is. So we get back to your point, yes? Because, of course, a completely unbiased model would be like flipping a coin, but again, we're not interested in that. So our experiment makes sense for the most part. So there's a lot that we need to do, but I don't want to tell you about this. What I want to tell you is that all of this is available. You can download it and use it on your device. So we're not going to steal anybody's data. You can do it on your computer, and if you want to contribute, of course, that's very welcome. So thanks, and now to Davide.
Okay, the live part. I will put the glasses on. Oh, nice. Okay, so given that this is a data science Milano meetup, okay, data science Milano doesn't matter, but data science meetup, I'm talking to also people into data. I can share some details about how we implemented it. And especially even before starting with the demo, that's also a call to action, meaning it's an open source project that we want to improve. There is a lot of improvement needed, but we want to improve together with someone else. So also for Alkemy, I think this is the first time we outsource something for a value that we have. So the front end is pretty basic. It's a web page. So this is the first improvement. But thanks for the people that work on this that are also in this room. And it gives you access to two options. Actually, at the moment, only bias is implemented. And here it contains all the implementations that are behind what Greta mentioned before. Opacity is the second module. This is also something interesting to discuss, like in terms of a community of practitioners. We have some ideas of what to implement on this from a methodological perspective, also with this interesting contribution from logic, but it's also something that could be open for discussion. But let's see the bias detection part. So what you can do here is to do two things. You can choose a data frame that can be either a text file, Excel file, or a pickle file, or you could even upload a pre-processing pipeline, meaning you could upload a Jupyter notebook that contains ordered cells that transform the data, because maybe you don't have access to the already pre-processed data. You can upload the dataset, the original raw dataset, the notebook, and also even the artifacts like one-hot encoding stuff or similar. Let's upload. I think it's already uploaded, but just to show you that that's not a screenshot, I will do this again. Open. You click to upload, and data frame uploaded successfully. Here you see the two analyses that Greta mentioned. Let's start with FREC versus FREC. So FREC versus FREC compares the relative frequencies of each subgroup of individuals with respect to a sensitive feature that we call root variable here. And with using two different notions of distance, total variation, or the JS, Jensen-Shannon divergence, checks if these two distances, let's say the group of males and the group of females, are too far away from each other. And the comparison is performed for each further subgroup provided by conditioning variables. So here I'll show you now in a moment. You can ask to check, for example, for some control variables, every group of these control variables, if for the male-female distance, we get a result that is worrying or not. So a bit more complicated to explain, maybe I'll skip this for a moment, is the aggregation function that is involved only for multi-class classification issues. In binary problems, this is not needed. And also another thing that we introduced very recently is the working directly on the probability outcome of models. So as you may know, a classification model will always output a number between 0 and 1 that we cut with some threshold, and we assign the individual with the predicted probability to the group 0, 1, or A, B, C, and so on. So the results are comparable but not the same. We perform experiments only on the class, so only on the binary outcome or the discrete outcome anyway. We didn't perform experiments so far for probability. This is another thing that we could do together. And finally, the other parameter is the threshold. So this is a threshold that can go from 0 to 1. And this is like if the distance is bigger than the threshold, then we raise a warning. Or we can set the threshold automatic. And here there are, as Greta showed, this automatic threshold is a function of 3 parameters. 2 of them are set by the user, and 1 of them is computed by the tool. The details of the theory behind is also reported in a paper that the group of Giuseppe recently brought to a conference in Rome, and will be, I think, published soon. And it's also inside the repository. So find it. Let's say that we put a high sensitivity with a threshold that is automatically found, and we decide to use as prediction the predictions. I didn't show you the file, It's really the most common data structure you can think about. It's real data from a research paper from a Taiwanese or Korean, I don't remember, bank institution. Of course, we couldn't use the Alchemy client's data for this demo, but it's a table. It could be everything. We have some sensitive features, some behavioral features of the payment behaviors, and the probability of predictions or the actual prediction already discrete. So I will use this column now. As root or sensitive variable, I will use the sex. And as a conditioning variable, I will use education and marriage. So let's say that and as you can see, I can't select the aggregation function because the tool understands that the sensitive feature is binary. So this aggregation is not needed. I can tell you more later about what is the aggregation, but I need to check the paper first. Okay, so I upload the information and I run the analysis. This is the page that Greta already showed, but this is produced live. And we have a few stuff. So first, the overall result. So if I don't condition with the modes, with the labels of the conditioning variables, but I only look on the population level a difference between males and females, do I find a relevant difference? Well, the distance is this one, and believe me, we should do the np.round on this. We have this in mind since always, but it looks cooler. Like, what are you computing? Like, so precise.
The 10 procedure.
Yeah,
Very fun.
This is the threshold that the system computed automatically. This is a standard deviation, but it's not relevant for binary problems. And this is the actual distance that was found. That is bigger, quite bigger than the overall of the threshold. So the system says false, meaning it's not true this check. This could also be inverted. What does it mean? Does it mean that these predictions are biased? I don't think it's that easy to say bias, no bias. For me personally, this is interesting as a warning system. So as a screening system that can check my predictions and tell me if I should be concerned or if this was expected. More interesting is that then we have the results for every subgroup. So for the Cartesian product of the conditioning variable labels with the same results. So the number of how many people are inside this group, what is the distance, the results of the comparison, and the threshold that is always the same. And here we have only the violations that are ordered by severity. Also the color indicates that the bigger, the one on the top has the biggest distance. In fact, this is 0.06 against a threshold of 0.017. You can click on the violation for a wannabe, and it will be analysis page. For the moment, it's just a contingency table that tells you for these two inside this group of education with the label 5, how males and females are performing with respect to the predictions. And we see that for the males, for the females, the probability of default is predicted much smaller than the one predicted for the males. So that's actually very simple. Like, we are simply checking if the machine learning models is treating very differently different groups, especially focusing on clusters of individuals that are similar for some controlling variables. And of course, as Greta said, having a machine learning model that treats everyone as the same is a useless machine learning model. A machine learning models must discriminate to be helpful. That's just how it is. if we want to help us in making decisions. The point is being aware of these discriminations and being capable of doing something if we find that the things are going on out of control. So imagine this system, and also the second phase of the collaboration is aiming also to that is embedded inside a monitoring system that can, on a daily basis or even real time, update the data analysts, the data scientists, but also the decision makers about the level of discrimination, the level of bias that the model has. The model will have, and we want that the model have this has this kind of discrimination bias, but we want to understand it very closely. So this is for the. Of course, you can also export the results, but FREC versus FREC. I'll just show you maybe what happens if I do on the probability. I can select a number of. We need to make this probability continuum discrete anyway. We can, I don't know, maybe do 3 bins, and the system will automatically, I'll show you something. It works. No, this is on the other page. But the results now will be computed not anymore checking the 2 classes, but checking the relative frequencies with respect to a variable number of bins for the predicted probability. The last thing I want to show you, or the next thing I want to show you, is the FREC versus REF. It will take a little bit longer than you imagine. No, not too much. But FREC versus REF is instead this other, maybe I can use the slides, kind of analysis. So the one I showed you now was checking 2 groups and seeing how different the system is treating them, machine learning system. This analysis instead check how my model is behaving, how close to some benchmark my model is performing. And in this way, in this branch of the analysis, we implemented so far only the KL divergence for a theoretical reason. And for the moment, it's the only one. I don't know if we will add other notion of distances. We have a similar automatic threshold thing. So the same option that we had before. We can, in this case, once again, decide to work directly on the continuous probability or on the computed classes, and we can set up the let's say predictions once again, and sex. You can see that the system dynamically prepared the cells for adding the reference distribution, meaning this object here, this histogram, is our desire, is our benchmark of what should happen. And I'm asked to set it up manually, meaning I have to tell the system what is the expected probabilities in the different groups. This is a bit hard to manage. Maybe we can find a better system, like uploading a config file for this, because if I, for example, I have a sensitive variable of 10 classes and predictions of 3 classes, I will have to manually input 30 cells, which is not great. But let's say now that I check for the distribution, where I imagine that males are equally, I expect an equal behavior for males between people that will default and people that will pay the loans, while I think that the females are better payers, so I expect 0.8 against 0.7. two expectations of female that will default, that won't pay back the loan. And I can check this again against marriage and education. You already you already see that it's getting more complicated. And also the interpretation is harder, because if I go in the results, now I have a double distance here. So I'm checking the KL divergence, the KL distance for male and for females against the expected distribution. And both distances are above the threshold. So I'm far from the benchmark for both the groups, males and females, overall. And this is true also in some of the subgroups. For example, if I focus only on people with education equal to 1, I don't remember what it means, and married people, the 1,000 people that are with these properties have a distance for males and females from the benchmark that is higher of what we consider a safe threshold. Now, I really didn't put any mind on the selection of the parameters, so don't take these results as relevant. It was the relevant results come from the experiments that are also in the repository. There is a notebook with them. This is all simply to show you that it's a very flexible system, but also easily hard to interpret. So once again, I see the value of this, especially in perspective for the future, as a part of a bigger monitoring system. But like someone should be somehow forced, an analyst or some responsible of the results, should be somehow forced to check these results. And the system could simply try all the combination of the parameters and perform an overall measure of riskness or of overall bias or tendency to bias. And this overall check is something that we are kind of putting in the next steps. Once again, all the potential results for every subgroups, only the violations. The very last thing is for Frec versus Ref. The last thing to be mentioned is that when we work on the continuous probability, we can either in this Frec versus Ref, apart from setting the number of beans, we also took care of avoiding what happens with KL divergence when the denominator is 0. For example, there are two adjustments that you can read here. One is simply removing is skipping the checks where there is the denominator equal to 0, and the Laplace is adding 1 to everything, right, Davide? More or less. And it works exactly the same. So just for be sure that, no. Okay, it's working the same. I took the wrong predictions, but the following is exactly the same. And here you see the dynamic of craziness. Okay, so next steps for sure. The application is available on GitHub, is Dockerized, so it's a Docker container. The front end is simply a Flask application because it was just for demo purpose. Next steps: implementation of the opacity, implementation of the overall risk definition, potentially other educational moments, and bringing this on in universities and so on, and attracting some interest. And also internally in Alkemy, that is probably the hardest part, make our colleagues understanding that this is useful also from a business perspective. The anticipation is preparing also for the AI Act, which despite every day becomes more relevant and more official, it still doesn't really get the attention of most of my colleagues. I don't know yours. Any questions about the tool or things you want to try?
Yeah. Okay. So let's assume I work in a bank, okay, and I have to check if my models, that long models, they are biased. Okay. Okay, so five are biased. Which option I do have to deal with this with the bias on those models?
So on a corrective level, you mean?
Yes, I mean, okay, I got that I can define if a model is biased for a feature, a particular feature, which kind of, how can deal with that?
Yeah, with the premise that we didn't focus on this so far, I can share, and you are all invited to do the same, what I got from this field. One important thing is that even if you remove the sensitive feature, that usually is not present, but even if you remove it, you can still oftentimes find that the model is able to discriminate with respect to the missing feature, simply because the data is rich of the influence of that feature. So if you are A or B, you will reflect that being A or B also in other properties that are represented in the data in other columns. So simply removing sensitive features is not enough. So there are systems that adjust the models, forcing it to be less accurate but more equal on the outcome. But it's there I really miss the almost the point. Then I wouldn't use the machine learning model at all, you know. But that's a decision of who is doing the. So often the systems that I saw for reducing the bias require a loss in accuracy, and you have to decide the trade-off. I personally think I don't believe in a fully automatic system in any industry, in any system, especially when people are involved, like HR or whatever similar application. So I dream, once again using this word, I dream a world where the model is used, or where the user of the model, you are telling me if I can get a loan or not, have access to a monitoring system in this way and can realize with the contextual information if the recommendation of the system is within the range of safetiness or something that you human should be considered twice or more. But that's my ideal vision. So
Human in the loop.
if we want human actually outside of the loop, it must be the agent of the loop. I see this human in the loop like the human is simply another piece of the mechanism. I believe the human should be in control of this, and also sometimes saying I can't use what the model is telling because it's with all the contextual information and the context around me, I don't feel safe. But that's absolutely my perspective. I don't know other perspectives.
If I may say something here, I agree with what Davide said. I also think that this is maybe one way, less sexy way to put this in words would be an awareness, right? So what you want is to be in the position as a human, to be in a position, first of all, to ask, if at all, with respect to what does my tool, my model, unfairly discriminates, right? So that's the first question that you should ask. What is the feature with respect to which I believe there is an unfair discrimination? Because we are all agreed that discrimination is the point. The question is whether the discrimination is fair or not. Yeah. Right? So then, if the decision maker establishes that the distinguishing feature is worth of being considered unfair, say typically gender or education in some cases, or I don't know, postal code, say, then this gives you the perspective according to which to say, okay, let me see what's around that specific feature. Let me see whether other information make me decide otherwise. And I think that's worth in itself, right? So I think that's, and certainly deciding to remove the feature and see what happens is a strategy, but it ends up giving back all the power to the machine, which I'm not sure we should, right? So what we should is gain the power back using the machinery that we can. So this is in a way one way.
So let me say, the aim of this BRIO model is just to, like a warning to say, pay attention, because the model that you are using, even though I'm not using like sensitive data, let's make an example. I recommend a system. I'm not using sex, for example, gender, but I have like as a feature, I don't know, the type of product I'm going to use. I don't know, like luxury bags or I don't know, football, something like this, no? Which could be like correlated to gender. And the point here is pay attention, even though you are not using like a sensitive feature, we can see that there is this kind of discrimination. And but the point is, okay, so now you know that it is. Now you need to choose what you're going to do,
Yeah.
because it's a risk.
And
Is that correct?
it is, and the responsibility must be on the human shoulders. Like delegating the last decision to a machine is also a way of escaping the final words on what we want to do. Like, does a bank have the right of denying you a loan because you are clearly likely to not pay back? Who has to pay for this decision? Like, or do we want to force the bank to give you the money anyway because we believe in a world where you must have this opportunity? But then who is paying for the loss that the bank is giving? And I believe no machine, no algorithm can answer these questions. It's a society and ethical also question. From a more pragmatical perspective, there is the monitoring of live system, but as the data scientist, I also like the idea of when you do model selections, and you compare 10 models. Now you compare with the performance metrics, but why don't we compare the models also with the risk or bias metrics? So I could have the overall check, and then I have two models that work the same in terms of accuracy, kind of. I would pick the less biased or the less risky one. And this is, I think, also missing in our data science daily practice. First, because no one taught us about it. In the university, at least when I did, there was no bias or data ethics course. And second, because we don't have the tools. Like if you scikit-learn or whatever framework you use, you had this already by default, you would probably read it just because it's there. So these are my points of view.
So tell me if I'm wrong, but in the end, I never thought about it this way. So detecting bias brought in by a feature is basically trying to understand the feature, the importance of this feature. So you're basically trying to look if some individual or feature interaction between feature is bringing predictive information, right, into the model. Can we say this?
So you could say that partially, especially if the feature is present in the model. But if sex wasn't used, what we would check for these predictions was how, with regards to the labels of controlling feature, like sex, my predictions distribute. If I'm systematically predicting that the females are the ones not paying back, even if I didn't use females, but then it's not measuring the predict. Indirectly, yes. I mean, in a way, it will always be that if the model discrimination and like decision boundaries making is what the model is doing, and so if we want.
Add something to that. So, of course, what Davide said, but also the interesting thing is seeing how more than one feature combined, which is not usually done in, for example, feature weighting techniques, right? Because this moment you can also check what combinations of features are the most likely to create bias, to detect bias. So you can also see together, like what kind of combinations are the worst.
And one way I was thinking about, let's say you're right, most of the time, especially in big data and big models, there's a lot of correlation among features, so the information, if you remove one, then the same information is dropped in. But if this is not happening and you see a drop in the model, one way is to try to use a little bit of causal assumption, because tell me what you think, but most of the times what we consider bias is that there's some feature that's bringing predictive information, but it's actually a proxy, because if you think about, should I predict a crime because of race, it's probably not the race itself. We don't have an assumption from a causal perspective that it's race itself causing. It's something that race is bringing as a proxy. So maybe you sit down and you try to think, okay, let me think what other information I can bring in. So I don't need to use race, but I can make the model as well. This is something, and one of the first models in AI in medicine from Oscar one, I guess, from Microsoft Research. So I don't remember exactly, it was something in pneumology. And one feature that was predictive of, I guess, dying of, I don't know, pneumonia, whatever, was if you add asthma, you have a reduced risk. Everyone said, what the heck, why this should be? And so they sit down, they start discussing with the physician, and it turned out because if you have asthma, you go much more often to the physician, so you're screening too, right? And in the end, they in this case, it was not biased, so they kept asthma, but they could also simply start asking how many times you go to a physician, right? So the model was not corrupted. In this case, this was not biased, right? They simply apply a little bit more reasoning on why this feature was predictive, and they were able to understand what was the real predictive feature and not the proxy.
This is a very interesting point. First, let me say, I unfortunately met people that would find a direct causal explanation between race and crime. I had this unfortunate moment, yeah, for that. You know, the people. It's interesting. First, this opacity here, I think, is also going in that direction. Meaning, the other way of looking at this problem is not at the bottom, but internally in the model. So not checking the outcomes, but understanding these causal paths, if possible, to model them. And the explainability or the absence of opacity can help in this. When it's the case where a model is used, especially in machine learning, this is often the case where you check the performance. Then what you want to avoid is that, like, the people with the asthma don't get access to medication because they are predicted to be healthier. Just because, and the model, if you simply constrain yourself to the results, this is the logical decision that the system would make. So this bias detection could be the first, at least I think we always imagine this in this way, like campanello d'allarme, warning bell, like alarm bell, whatever, to then open the box, which it's much more complex, as you would know, right? Like causal analysis is way less easier than training a machine learning model. But very interesting. Maybe we can think how to incorporate.
Yeah, I wanted to add something. I agree, but one error we shouldn't make here is the assumption that this, what you have seen, is in any way causal explanation, right? Because no, just because so it's right what Davide said about the opacity. The idea of developing the opacity module is to go towards sort of counterfactual analysis, right? So once you have an overview of what combinations of features provide you with certain relevant decision that you might want to investigate, then you might want to do counterfactual reasoning on that. What happens if I flip this, I drop this, or what happens if I add this other thing, right? So the sort of Pearl ladder, highest level of the Pearl ladder, where you actually intervene on the assumed causal relation to see whether they are effectively causal relations, so they merely qualify as correlation. But in this sense, the bias model sort of provide you the structure on which you might want them to work to investigate the causal relations.
And actually, maybe that's an opportunity because proxies are always imperfect. So if you start thinking in a more causal way or whatever, maybe you end up removing the feature that brings the bias and having a better model, even in performance.
Yeah.
You get to the source of the
Information and the variability. Yeah, absolutely. It's quite surprising how, at least from my vantage point, this approach is still not much followed or proposed in projects. Even like we did, it's a completely different topic, but uplift models for understanding like the causal effects on on marketing campaigns, and despite the almost no effort in doing that because we prepared it already, it's hard to convince people that it brings you value. Like compared to a simpler model, it's also culturally more difficult. But side note, other comments or
Yeah, just another question is, so you said before that you are trying like to use the BRIO also in Alkemy for your project or your customer. But the problem here is, are you like imagining, figuring out how to like summarize the report that the bias module exposed? Since okay, we are data science Milan, so we do understand, but I would say that maybe I don't know, domain expertise or I don't know, some stakeholder. Maybe with 10 precision. No, I mean.
we want to add some digits actually.
Exactly. No, I mean you are thinking about something like to summarize. I don't know, setting up some default threshold, for example.
It's still in progress. This brainstorming. We had also the idea of a dashboard, something more nice and interactive, but it's an open.
I think the idea would be a guided process, right? So like a sort of maybe virtual assistant that tells you, okay, what are you looking for? What is your fear that you might be trying to extract, sort of doing sort of requirement solicitation from the users in order to fill in all the that would be make it super friendly.
Right? I know that you are super expert with OpenAI and LLM, so I would say that it could be possible. It's feasible.
Yeah. No, don't let me comment.
Okay.
Other questions or I see someone hiding behind the wall, Francesca. Okay, if there are no other questions, once again, thanks a lot for coming, even with the cold and so on. And please check it out, our website, the BRIO website and repository. And yeah, and if you like to join in this work together, just contact one of us. Thanks again.